All right. Multiplying and dividing rational expressions are essentially the same thing, because if you remember your multiplication and division rules for fractions, they're literally the same. Just to do a quick recap from like grade 5, 6, or 7. 3 divided by 7 divided by, let's say, 14 over 25. To do this, all you need to do is flip the second fraction and change the sign into multiplication. This becomes what, 75 over, what was that, 2898? That's it. So flip the second fraction, change the sign to multiplication. So division is basically multiplication with one, added extra rule. So let's do this. 2x squared minus 8x over x squared all right, so I just rewrote the question because I like to waste time, I guess. Let us just factor. So let's factor the top. What's common between this guy and this guy? And you can factor out a common factor of 2 and a common factor of x. So if I divide both of these by 2x, this becomes x minus sign. This becomes 4. Denominator. What are two values that add up to -3, and the same two values, when multiplied, give you a value of -10? That's looking to me like -5 and +2. And yeah, that makes sense. So this is going to be x minus 5, x plus 2, times, oh wait, sorry, I didn't flip it yet. How does this factor out? Well, that's -9 and 20, so two values that add up to -9 and multiplied by 20. 5 and 4, so -4, -5. Okay. So we cannot cancel out any common factors yet, because the first thing that whenever you have a division sign, you always have to flip the fraction. So let's do that right now. So if a lot of students think, oh, x minus 4 cancels out, that's actually wrong, because what you need to do is rewrite this as follows. Okay, so now that I've flipped the second fraction, I can now look at common factors, because I'm multiplying. You can only do that when you're multiplying. What's common here? Well, I know I have an x minus 5 here and an x minus 5 here. The x minus 4s cannot cancel because they're on the same side. But I do have an x here, and I have x squared. If those are the same things. I have a 2 here, and I have a 4 here. That changes the 4 to a 2. And I believe that's all the common factors that we can cancel out. So this becomes x minus 4 times x minus 4. Oh, that's it. And the bottom becomes x plus, well, there's a 2 and there's an x. So 2x times x plus 2. And we're done. Are we done? The answer is no, we are not done. Remember that we need to state restrictions when it comes to these this whole unit, essentially. So what are values that x cannot equal? And you cannot start from the final step. Remember, you should always start from the very first step here. Well, I mean, the second step here, because we need to factor. That's the first step. All right, so let's take a look at the denominators. X cannot equal 5 because of that guy. -2 because of this one, 4 because of this one, and 5. Well, we already got 5. So these are the restrictions. But hold on. We flipped this fraction, meaning we got a new denominator. Because now this term is now in the denominator. It's a new term. We need to figure out what is the restriction upon that term. And that's just 0. Because it's just x. X cannot equal 0. So we have 4 restrictions. So don't forget all 4. And yes, the original restrictions that were in the denominator also stay, because remember, at any point in time, if you have a denominator, it cannot be 0. So you have to take the restrictions in 2 steps when it comes to the division questions, division type questions. Initially, and then usually when you flip the division sign. So yeah. And there you go. We have our restrictions, we have our simplification, and we're done. And the final example is adding and subtracting. Okay, I should have enough time to do one of each. Remember, if I'm going too fast, that's kind of the purpose, because I want you to be able to watch the video, because it's being recorded, it will be posted, and you can hopefully learn, pause whenever you need to, and practice the practice sheets. Okay, so here we are adding 2 fractions. And if you remember anything about adding fractions, you need to have a common denominator. Are these denominators common? Obviously, no, they're not the same at all. They look very different. So how can I make them common? Well, before we do that, the very first step when it comes to this whole unit, essentially, is we need to factor everything. Just makes our lives easier. Now, the first fraction is already factored. The top of the second fraction is already factored. And now we need to factor, just this one quadratic term. Pretty straightforward. 2 numbers that add up to 6 and multiply to 8. So that's going to look like 2 plus 4 and 2 times 4 to me. This becomes x minus 2 over x plus 2 plus sign x plus 10 over x plus 2 x plus 4. And I recommend putting brackets around every single factor. And just so you know, I should mention this, I haven't mentioned this earlier. There are invisible brackets here and here and here. So these are called implicit brackets. Usually they're there to separate the top and the bottom. So meaning you need to simplify the numerator before you do the division. So there are brackets there, in case you're wondering, oh, where the brackets come from? They're invisible, they're there. You just got to put them in. Okay. Now let's look at the denominator. Are the denominators common? Well, kind of. They have similarities and differences. The similarities are x plus 2. They both have an x plus 2 factor, but one of them has an extra factor of x plus 4. So what you need to do is you need to multiply the fraction that's missing that extra factor. I will multiply the first fraction, both top and bottom, by x plus 4. Now if I do this, the denominators are going to be common. So what is x plus 4 times x minus 2? Well, you have to use some grade 10 FOIL techniques. That's going to be x squared minus 2x plus 4x minus 8. And here's a very, very important thing to save your life. Do not expand the denominator. Keep the denominator in factored form. That is how we wanted.